All right. So before we dive into things here, that second exam, let's see here, should now be kind of counting towards your grade. So we've got another exam score in there. Excuse me. Um, the average, I think, was for this section, across the two sections, the average or the mean was like 76 or something. And then I think the median was like just below an 80. So overall, kind of usually where I like to see the average is a little bit lower in the first exam. That's expected. Also, maybe the lockdown browser had a role in that. We'll be using that again in the final. So this class, moves quick. It's a summer class. So we'll start module 10 today. Do that today, tomorrow. Module 11, Wednesday, Thursday. Start module 12 on Friday. Finish it next Monday. Next Tuesday, Thursday, do module 13, review Thursday, the final exam next Friday. So it kind of follows similar, these kind of 2-week chunks into each exam. This week, I actually need to add it here. Might as well just do it while we're here. After tomorrow's class, you'll kind of see that module 10 quiz pop up. We'll have participation quizzes from these today and tomorrow. And then module 11 will kind of have its quiz and participation quizzes. Those will all be due at the end of the day, Sunday. Module 12, right, we'll kind of finish next week. So module 12 and 13, those will have their quiz due dates be that Thursday next week before the final exam. So about the end of the day next Thursday. So a little bit quicker turnaround on those. Excuse me. And I'll also, after class, get up the next module 12 reading as well. That'll be due before we start module 12 this Friday. So you'll have, some time to get on and get that done. But other than that, that should be all the housekeeping stuff. So we've got like the practice problems for module 10 up there already. You can start to kind of take a look at those after today's class. Other than that, I don't have anything kind of logistically to mention before we just hop right into material. So any questions for me before we dive into things here, material wise? Okay. Excuse me. So this class is not cumulative. However, we will use I always say it's not cumulative, and I won't ask you module 8, 9 type questions in the final, but it's comprehensive in the fact that we're going to keep using things we've talked about and just build on them. So module 10 is about perfectly competitive markets. So all the rest of the semester, we'll be talking about just markets, just different types. So module 10 is about perfectly competitive markets. So we're going to define some of the characteristics that we need to have a perfectly competitive market. It'll be kind of our baseline, right? So we usually say there's no barriers to entry. So you don't need to, get government permission. Existing firms, can't create their own governing bodies to keep other firms out. So firms can enter and exit this market freely. We're going to have many buyers, many firms. That'll kind of be a characteristic that that produces an additional result, an additional characteristic. So I'll skip ahead here, which is that because we have many firms and many buyers, no one firm or buyer is going to have any influence over the price. So we say every firm or every producer or every consumer is a price taker, right? They have to pay whatever the price of that good is on the market. Now, we're also going to assume here that we have perfectly homogeneous products or perfect substitutes. So I always use the example of gasoline because 87 unleaded gasoline, everyone's producing, it's the same thing, right? Now, you could think about, well, how many goods really are truly perfect substitutes? Even bottles of water, you could argue, aren't quite the same. That's a different type of market. We'll talk more about. It's the very last module, so monopolistic competitive. But we've got to walk before we can run. We need kind of our baseline to compare to, which is these perfectly competitive markets if we did have perfect substitutes. And we have many buyers, many sellers. Nobody has any influence over the price. So this is the idea. If I got 2 gas stations right across the street, if I charge more for my gas, what's going to happen? Everybody's going to buy from the other person. Okay. So, see if I can get this to go away. So perfectly competitive markets would not be the following, right? So we need free entry and exit. We need can't be any legal restrictions to getting into that market. You can't have any one company controlling all of a scarce. So this would be like if someone owned all of the oil reserves in the U.S., just one company. We can't have control of a scarce resource like that. Existing firms can't create barriers. And then we also don't want to have any barriers due to just like geographical. So, this is like not quite as applicable these days now that we have, the ability to move product pretty long distances, even over oceans. But we will talk about once we get to next module monopolies. There are still some natural monopolies that we still haven't overcome some geographical barriers. So none of this should apply to our perfectly competitive markets, right? It should be easy. A firm, I can start producing this product. I can join that industry right now, right? So, what are firms in these perfectly competitive industries going to do? So we talked about some of this already, right? But they're essentially going to maximize economic profit. So we talked about what are economic profits. Firms take into consideration both their explicit and implicit costs, right? But then profits are really just going to be the difference between our total revenue and those total economic costs. Okay. So we're going to try to maximize economic profits, and they're going to do so by choosing the quantity they're producing, right? So they're essentially choosing how much they produce. In that production decision, they are going to stop at the quantity that maximizes economic profits. So if we have many firms and buyers, everyone is a price taker. No one should have control over the price. The marginal revenue of each firm should simply be the price of the product they're selling. Give you a little bit more of an insight into this in a second. But the marginal revenue of these firms, if I try to charge a price that's different than everyone else, so I try to charge $1 higher per gallon of gasoline, what happens? I can't sell any. It's a perfect substitute. There's many other sellers out there. Everyone else just goes and buys from somebody else. Okay. So what's going to be true is we're going to have a difference now between the market demand and the individual firm's demand curve. So our market demand, right, looks like it did before, and market supply, upward sloping, market demand, downward sloping. The equilibrium, we still identify the same way, where does the marginal cost equal the marginal benefits on the market, or where does supply equal demand? So if we have this equilibrium price, right, because each firm, you can't sell any of this product unless you charge what everybody else is charging. Their marginal revenue, how much money they make on each unit they sell, will simply be that equilibrium price. So the firm's demand curve, how much people are willing to buy from them, well, it kind of depends how many other firms are out there, what's the overall demand, but essentially all these different quantities that could be demanded from the firm are only going to exist if they charge the same price as everybody else, or they're charging that equilibrium price. Okay. So our firm's demand curve is going to be kind of horizontal. A lot of the times what I'll do is kind of write the firm's demand as kind of lower case D, market demand uppercase. Now I'll kind of write market next to market demand sometimes, and firm next to the demand for the firm's demand sometimes. But this is going to be kind of a notation that you see in the top hat, also other sources if you're kind of looking up additional sources. Okay. So before we get to a demand increase, you don't want to look at me. Look at this. Okay. So I want to be a little bit more specific about the firm's demand curve. So we think about that equilibrium price, and I said that equilibrium price will be the firm's demand curve. Okay. And that's because if I try to charge a price any different than whatever that equilibrium price is, so we had 3 was our example. If I try to charge $4, how much will people buy? Nothing from me. They'll go find another buyer. There's many buyers out, many sellers. There's many sellers out there, so they'll find another seller and buy from them. So essentially, like our firm's demand curve, if we want to be technical, it actually like runs along this intercept and is 0 for every price above that equilibrium. And then as soon as they start charging that equilibrium price, that's where they can sell as many units as they want, as long as the number of units is something below market demand. And we won't ever kind of look at, eventually I think we'll get to see why, but we won't look at quantities for the firm that would be above market demand. Why? Well, because we said there's many sellers, so we always know each firm will have a portion of the overall market demand. Okay. So we know the quantity that the firm chooses to sell will always be a fraction of whatever the market demand is. Okay. So this is our firm's demand curve. We said, where does this come from? Okay. Let's see. So we've got, you can start drawing these kind of side by side. And here I said, a lot of times I'll use like lowercase. So here's the quantity of the firm. Here's the quantity of the market. Here was my supply of the market. Here's my demand curve in the market. That resulted in some equilibrium price. We'll kind of start out thinking about, here was our initial supply curve. So the firm's demand curve, we would say, is here, or because that price is what I'm selling the good for, that becomes the firm's marginal revenue. So the firm's demand curve would be the same as their marginal revenue curve. And we'll use this a little bit later on. Let's say that we had more firms join this industry, right? Or this market, or we could even have something that, a new cost-cutting technique so that we see an increase in supply. Now, it's an increase in the market supply, right? So if we saw something like the number of firms or lower cost, some cost-cutting technique, we would see an increase in the market supply, which would do what? Well, this is where we're using things we've already talked about. It would actually lower that equilibrium price. What is the new firm's demand curve, right? So the new firm's demand curve or their new marginal revenue curve would now be a little bit lower. Okay. So, somewhat intuitively, how does this make sense? Think about it this way, like if more firms join the market, that's going to increase the overall market supply, but maybe each firm, right, they're selling at a lower price, they're going to face like a smaller portion of the overall demand. That's not completely technically correct, but it's a good way to think about it up to this point, right? We got to walk before we can run. So supply changes, anything that changes that equilibrium price will also change the firm's demand curve. And the firm's demand curve will be what we call its marginal revenue. Okay. So we're going to start making this link between the market and then the firm's decision. Now, this isn't the firm's decision yet. This is just the demand curve they face, but we've got to start out there, right? So we could have a similar sort of thing going on. Let's say instead of a supply increase, let's say that there's something in this market that increases demand. Maybe this is a normal good. We see an increase in income overall. What happens? Prices will go up, right? If that equilibrium price is higher, well, what's going to happen to the firm's demand curve? That's the price that they're charging, or that's their marginal revenue. So the firm's demand or the firm's marginal revenue curve, in that case, would actually go up. So we can see changes in the market that decrease the firm's demand curve. We can also see change in the market that would increase the firm's demand curve. Okay. Any questions there before we keep moving here? It's not too bad yet. So we're thinking about the firm's demand, and that represents their marginal revenue. How are they going to choose a quantity that will maximize economic profits? Well, let's think about, when is production profitable? If we take our very basic definition of profit, it's just total revenue minus total cost. So if our revenues are greater than our costs, right, we would have positive profits. If they're exactly the same, we'd have zero profits, or call that kind of the break-even point. And if total revenue is ever below total cost, we would say the firm is incurring a loss, or we have negative profits. Okay? So we have three different potential scenarios: positive or negative profits, but also this point where they're zero. Okay. So if I had like a little table where I had total revenues and total costs, and I'll kind of keep using this example for the rest of the class today. Here's all the different production decisions, the quantities that the firm could produce. Here's the resulting total revenue. Here's the resulting total costs. How would I calculate profits? Simply the difference between the two. So if I'm looking here, where would profits be maximized? Well, here they're negative, but they're at least becoming a smaller negative value. So they're still going up, they're going up, they're going up. At 9.5, okay, they're just barely going up here. Okay, now they start to go down. So what profit is the highest? 9.5. That happens at a quantity of 10. So a couple things to point out about this. We can also gain some additional information. If this firm produced nothing, they still had costs. So what must this firm be in? The short or the long run? Well, we said in the short run, even if I don't produce anything, I still have to pay my fixed cost. So anytime we have total costs that are above zero, we know that this firm is in the short run. So we got this firm in the short run, they've got some fixed costs. Now, as they produce more units, right, that fixed cost stays the same. And initially they're adding a certain amount to their cost, and maybe they've got gains from specialization. So I think I've got a slide in a second. We'll actually compute the marginal cost. How do we do that? Well, it's the change in my total cost divided by a change in quantity. Here, the quantity changes are ones, so that makes it easy. But eventually we said gains from specialization go away, and eventually my marginal costs, or how much my costs are going up by, starts to go up by even more. Like, down here, right? My costs were going up by 2, 1.5. Now down here, they're going up by 13, 15, right? So those increasing marginal costs are really going to impact those total costs a lot more as I produce a higher number of units. Now, the total revenue, you'll notice, is always a jump of 4 here. Why? Because when I sell a good, I have to sell it for that equilibrium price. So what is total revenue? Oops. Simply price times quantity. Okay. So each time I sell one more unit, how much more revenue am I earning? Whatever that equilibrium price is. So here, the change in total revenue should simply be the equilibrium price, which here must be, what, $4. Okay. All right. So before we get to kind of analyzing where that, we said I could find profits from total revenue and total cost and see what quantity had the highest profits. That's an easy way of determining where profits will be at their maximum point. We have additional ways that we can calculate this as well. And we also have different ways of visualizing this. So one of the ones that I'll use, and kind of jump the gun on some things here a little bit, but I think it'll be worthwhile. So if I'm looking at marginal revenue, or sorry, not marginal revenue. If I'm looking at total revenue, well, if I don't sell anything, my total revenue is 0. Then as I sell more, every unit I sell, we said, well, what's the slope of this curve? Well, what is the slope of a curve? It's if I take a derivative of it, or I find the change. So what is the change? Well, here, I'll write it more friendly. What is the change in total revenue coming from a change in quantity? That's simply going to be my marginal revenue, which we said will be the equilibrium price. So the slope of our total revenue curve, or that marginal revenue, is simply that equilibrium price. Okay. Now, what will our total cost curve look like? So we're actually going to end up with a total cost curve that looks something like, let me see if I can get this to be. So I want initially my margin, yeah, so I could do, I'll make sure I draw it big enough here. There we go. All right, so there would be what my total cost curve looks like. Okay. Now, when my total cost is equal to my total revenue, what's going to be true at these quantities, right? Well, if total cost is equal to total revenue, we said profits are simply my total revenue minus my total cost. Profits at these 2 points would be equal to 0. Okay. Now, if I produce past this quantity, what starts to happen to the difference between my total revenue and my total cost? Well, there's now a difference between the two. Total revenue is higher than total cost. Now my profits are positive. As I produce more, what's happening to the gap in between my total revenue and my total cost? It's getting bigger and bigger. So notice here, moving from here to here, I'm going from really small profits to larger profits. Right? So I want to find that quantity that maximizes profits, or that difference between total revenue and total cost is at its greatest. Now, if I continue to go past this point, what starts to happen? Well, now that gap is getting smaller and smaller. So if I continue to produce past this point, I'd actually just be decreasing my profits. Okay. So visually, that point, that quantity where the difference between total revenue and total cost is its largest, that's going to be the point that maximizes profits, because profits are simply the difference between total revenues and total costs. Okay. So that was what I kind of left open for that graph there. Let's get this off the screen. Have I been muted for a while, or did it just happen? Anybody want to help me out? Anybody there? Okay, just making sure. So my marginal revenue, right? Or where was I at? Okay, perfect. We can compare total revenue to total cost, but we've already talked about people make decisions and firms make decisions on the margin, right? So we looked at marginal cost. We also can think about marginal revenue. So that's just the change in total revenue coming from a change in quantity. Just like marginal cost was a change in the total cost divided by a change in quantity. Okay. So if I think about the optimal output rule, what this is really going to say is the point where profits will be maximized is where the total cost is where, or the point where the difference between our total revenue and our total cost is at its largest, will be the point where the marginal revenue of the last unit produced is the exact same as the marginal cost. Right? Or we will produce as long as the marginal revenue is greater than or equal to the marginal cost. So the point where we'll be kind of indifferent is where they're equal, and that's where we'll stop. So to kind of think about why, let's think about what our profits are. Total revenues minus total costs. So let's say now I want to instead find marginal profits. Well, what that's really saying is the change in my profits coming from a change in quantity. So I don't know everyone's math background. We'll talk about derivatives here a little bit. When you're finding the change in, say, y from a change, that's a derivative, right? Profits are a function of quantity. I'm finding a change in profits as a result of the change in the production or the change in the quantity of the firm. Well, if I'm simply subtracting these two, I can take a derivative of total revenue, a derivative of total cost in respect to quantity. Well, what is the change in total revenue over a change in quantity? That's just my marginal revenue. Change in total cost over the change in quantity is just my marginal cost. So the change in my profits is going to be the difference between marginal revenue and marginal cost. So as long as marginal revenue is above marginal cost, I know that the change in my profits will be positive. Well, that's a good thing. That means my profits are increasing. Anytime marginal revenue is less than my marginal costs, well, then the change in my profits from producing more would be negative. I'd actually be decreasing my profits. And then the point where they're not changing will be when they're exactly the same value. That would be the change in my profits would be equal to 0. That's going to be the point where our profits are maximized. Okay. Excuse me. So I'll give you a visual here in a second, but let's just think about it using some numbers. Okay. So I'm using those same revenues, same costs we had before, and the exact same, if we calculate profits, we'll have the same profits. Notice my marginal revenue, if it's the change in total revenue coming from a change in quantity, every time I sell one more unit, the change in revenue is the price, that $4. So if I calculate the marginal revenue at every quantity, it's going to be the change in total revenue is 4 over a change in quantity of 1. It's always going to be 4. So my marginal revenue, or that slope of our total revenue curve, is constant. Now, because we have diminishing returns and gains from specialization, our marginal cost curve we said is going to be what? Initially going down, and then eventually, when diminishing returns take over, it starts to increase. So notice here, if I find the change in my total cost divided by the change in quantity, initially it's what? 3.8. And then here it's only, what, 3 over 1, so 3. Initially, my marginal costs are going down. So what must be happening from a quantity of 0 to 6? Well, my marginal costs are decreasing. Right? Well, if my marginal costs are, I have gains from specialization. Notice what's happening then to the difference between marginal revenue and marginal cost? It's getting larger and larger, or essentially how much I'm adding to profits is getting higher and higher. So as I produce more, when marginal revenue is above marginal cost, my profits are going up. So that's going to continue to occur as long as my marginal revenue is above my marginal cost. So even once diminishing returns take over, Yes, the difference between marginal revenue and marginal cost is getting smaller and smaller, but that still means I'm adding something positive to profits. Now, once I get to a quantity, the very last quantity where marginal revenue is greater than or equal to marginal costs, that was the last unit that added a positive amount to my profits. If I continue to go past that point, at a quantity of 11, the additional revenue I'm making from the 11th unit is $4, but it's costing me an additional 5.4. So what have I done to profits? I've decreased it by $1.40. So as soon as marginal revenue, right, is less than my marginal cost, now my profits are going to be going down. So that point, where total revenue minus total cost is maximized is going to be that last quantity where marginal revenue is greater than my marginal costs. And if we had a point, I didn't have it in this example, but if we had a point where they're equal, what would happen to my profits? Well, the additional revenue, if that was the same as my additional cost, the change in profits would be 0. So we'd say the firms are indifferent. They'll produce up to that point. We know they won't go past it, but we don't know if they're indifferent about producing that quantity or not. In this case, I left one out just to make it a little bit more obvious. Okay. So visually, what does our optimal output rule look like? Right? Well, if I have this constant marginal revenue, right? It was simply whatever that equilibrium price was, $4 in this example. I then have my marginal costs, which eventually I know will start to increase because of diminishing returns, right, to labor. All I'm looking for is every quantity where marginal revenue is greater than my marginal cost, I know that my profits are going to be increasing. The point where they're equal will mean I'm adding nothing to profits, or profits have become maximized. Any quantity past that point, now my additional costs are greater than the additional revenues. I would just be creating negative profit or decreasing my profits. Okay. So before we kind of get to this perfect competition thing, got another way of thinking about and kind of trying to solidify this idea of what's happening with our profits. Okay. Oh, I don't want to do this. I want it to be up and down. Sorry. Think it'll stay on the screen easier this way. So let's say I've got quantity of the firm, and I want to try to be able to keep this all in the firm. So we had my total revenue, and I said, here was my total cost. Okay. So, excuse me, if I'm thinking about the slope of this total revenue curve, we said it's constant. So here was like my marginal revenue. And that was simply going to be whatever that equilibrium price in the market was. That's how much money I was making for every unit I was selling. Now, we said before, this point where, and I'm just kind of eyeballing it here. So if I'm a little bit off visually, I'm doing my best here. But it looks like the gap is the largest between total revenue and total cost at this quantity. So we'd say this is kind of the profit maximizing quantity. So what should be true then is if we looked at our marginal costs, initially they're decreasing, eventually diminishing returns take over. And what should be true is that point where profits are at their maximum point, this will be the profit maximizing quantity. We're still looking at the quantity of the firm here. It's just now we're looking at the marginal revenue, marginal cost as opposed to the totals. Okay. And what should be true at this point is my marginal revenue is equal to my marginal cost. Okay. Remember, these marginal, they just represent slopes. So you'll notice the slope of my total revenue curve is always the same. Whenever I've got quantities down here, what's true about the slope of my marginal cost curve? It's a little bit flatter than the slope of my total revenue curve, right? Or the slope is a smaller value for cost than it is for that total revenue curve. Now that's going to be true until we get to this point where at a certain quantity, the slope of our total cost curve, which is our marginal cost, is exactly the same or is parallel to the slope of our total revenue curve, what's the slope of that's marginal revenue. So when the slope of the total revenue and the total cost curve are the same, what that's really saying is the marginal revenue is the same as the marginal cost, okay? For every point below that quantity, whenever the marginal cost is less than, or anytime the total cost curve is flatter, well, every unit here, we're going to be adding to profits, right? The additional revenues are greater than the additional costs for every unit here. So you can almost think about like the difference in between those. This is like the profit gained, this difference, for every single unit, right? The difference between the additional revenues and the additional costs of that unit. If we were to produce past this point, well, what happens now? Now the additional costs are greater than the additional revenues. So like everything in this range would actually be creating negative profits, or would represent a loss of profits if we were to produce past this point. And I say a loss of profits, it's a loss of profits relative to that point where they're at their maximum. I could still have positive profits overall, but I've went past the point where certain quantities now will be creating a profit loss, right? Or I will be moving away from that profit maximizing point. Okay. Okay. All right. Excuse me. So, with that idea in mind, we now can hopefully have a little bit better of an insight as to why the profit maximizing, well, I can leave this up. I think it still shows to you if you want to see it. The profit maximizing quantity is what it is, right? We know that as long as the marginal revenue is above the marginal cost, and the marginal revenue is simply the firm's demand curve, we know that for all of those units, we're going to be adding to our profits. Well, adding to our profits is a good thing. We'll stop as soon as the additional costs are greater than the additional revenues. Okay. So here, if I had a demand increase, well, what's that going to do in the market? That's going to shift my demand curve to the right. So once again, this could be like a normal good, and I see an increase in income. Pushes the price of that good up. Well, that's the new firm's demand curve. Notice anytime I have an increase in the market price, that will increase my firm's demand curve. Well, intuitively, if the price of a good is higher, should I be producing more or less than I was before? More, right? That the price all of a sudden is higher, I'm going to want to sell more than I was before. Sure enough, for all the units in this range, before, at the old price, the additional revenue I could make was less than the additional costs I would have to incur. However, now at this higher price, the additional revenue I can make is greater than the additional costs. So now it makes sense to produce these because the additional profit I can earn will now be positive from those units. So anytime we have a demand increase, we're going to see that the optimal quantity of for the firm also increases. There's going to be some units that didn't make sense to produce before, that weren't profitable, that at this higher price are now profitable. Okay. So just to kind of get more examples of this, we could also have a similar thing happening if we have shifts in supply. Okay. So let's say I started out and I've got my market, I've got my firm, here's my market supply, here's my market demand, here was the initial equilibrium price. We said that was going to be the firm's demand curve, which also represented their marginal revenue. We then also, and here I could even do, let's say we don't have any gains from specialization, so here is our marginal cost, right? So the point or the quantity for the firm, and here I'm going to write this in like this just to make a point. Sometimes I will differentiate instead of using like E's. I wouldn't typically call this like the equilibrium quantity of the firm. I would call this the optimal quantity. So a lot of times you'll see kind of the notation used outside, of this class even is a star, right? That represents this as kind of the optimal quantity for the firm. It's the quantity where the marginal revenue is equal to the marginal cost, or I know that at this point, this should be where profits are maximized, okay? Now, what happens, like in our previous example, I said, what if there's more firms that enter this market or something that would increase supply? Well, we can get some kind of counterintuitive results. So I just want to identify before where the quantity of the market was. Notice if I see a supply increase, this is where sometimes, especially now in the latter part of the class, we might get some counterintuitive results. So it's great when things seem intuitive. Sometimes they're not in economics. So higher or increase in supply shifts our supply curve to the right, results in the equilibrium price being lower. Okay. So the firm's demand curve after this supply change or supply increase is going to push the firm's demand to be a little bit lower, or their marginal revenue is lower than it was before. Well, if I can't make as much money off the goods I'm selling, am I going to want to sell more or less than I was before? So this kind of result, and we'll call this, I'll call this Q star 2, right? Well, the amount that the firm's going to produce is actually going to go down, right? Because every unit in this range, at the higher price, it was profitable. The marginal revenue was above the marginal cost. After that price change in the market, it's no longer profitable to produce these units, so they're going to lower their production, right? This will now be the quantity that maximizes profits, or the last unit where the marginal cost was greater than or equal to our marginal cost. So the counterintuitive result is, okay, yes, prices went down, each firm sold less or produced less. How then did the quantity in the market actually go up? What we would have to have happen is we had more firms in this market, right? That was one of the things that could drive supply increases. If more firms enter this market, we could see that the quantity goes up, but each firm could be producing less. So I'll give you a very easy example with numbers. I shouldn't say easy, basic. Let's say I had 2 firms producing 100 units, right? I then see supply increases, another firm enters, so now I have 3 firms, and they're each producing 75 units. Well, what's the, each firm before was producing 100, now they're each producing 75, but I've now got 3 firms, so the total quantity wouldn't be 200, it's now what? 75 times 3, or 225. So a little bit counterintuitive when we're thinking about supply shifts. We can actually see the quantity of the market go up, even though the quantity of each firm actually goes down. Okay. And then we have kind of our demand shifts as well. Those work a little bit more intuitive, where like the market quantity and the firm's quantity move in the same direction all the time. Okay. All right. Any other questions before we keep moving here? Kind of think about some other ways to calculate profits that will help us in making a different type of decision that firms have to make, not just the optimal. We kind of start with this optimal production rule, but gets a little bit trickier. So we started out with our profits simply being total revenues minus total costs. I'm going to do a little tricky algebra here to get us to a equation that's really saying the same thing using different values. So if I take total revenue, we said that was just the price I'm selling each good for times the good number of goods I'm producing. Total cost, I'm going to just multiply that by 1, quantity over quantity. So that's not changing anything here. I'm then going to rearrange this, right? Kept this part the same. Total cost over quantity times quantity. Didn't change anything here. But what is total cost divided by quantity? For module 9, we said that was average total cost. And then if I'm multiplying these both by Q, right? Well, I can just kind of redistribute this. So I've got quantity times the difference between price and average total cost. So what does this help me see? Anytime I'm producing at a quantity where the price is above my average total cost, what would be true about profits? They would be positive. Positive times a positive. What if price is below average total cost? Positive times a negative. Well, there, my profits would be negative, right? So to kind of give you just a quick kind of visual of this, and then we'll kind of look at a table. But I think this is helpful to see this first, maybe. So if I've got my average total cost curve, we said it's going to have some kind of U shape to it. We also said my marginal costs, hopefully we remember this, but it intersects my average total cost at its minimum point, right? So if I'm thinking about different prices, anytime that equilibrium price, so if this was the equilibrium price, what would profits be? Well, remember, the equilibrium price is the firm's demand curve, which is also their marginal revenue. So marginal revenue equals marginal cost. At that same point, we said another form of this profit equation, I just kind of rewrote a little bit, was this. So if price is equal to my average total cost at that minimum point, here my profits would be equal to 0. Okay. Now, if the price ever falls below that minimum point of the average total cost curve, it's going to intersect my marginal cost somewhere down here, right? So this was kind of the quantity where profits were equal to 0. Any price below that, well, my price is going to hit, my marginal revenue is going to hit my marginal cost down here. That's going to be below my average total. So if my price is below my average total cost for any price in this range, what's going to be true about my profits? Well, if average total cost is larger, negative times a positive amount of production, I'd end up with negative profits. Okay. And then anytime the price is up here, well, now my marginal revenue is hitting marginal cost at a quantity in this range. For every quantity here, well, now those prices would be above the average total cost. So what must be true about profits in that range? Positive times a positive, there I would have positive profits. So when price is equal to that minimum point of your average total cost, that's where profits are equal to 0. That's the quantity where marginal cost is equal to marginal revenue is equal to the minimum point of the average total cost, profits are 0. If the price falls below that, well, intuitively, if I've got 0 profits at this price, when the price goes lower, oh yeah, that would be now my average total costs are higher than these prices, my profits will be negative. Anytime the price goes above that point, well, now my marginal revenue is going to hit my marginal cost, or my price is going to be above the average total. So now I'm going to have positive profits. Okay. So we kind of have these two ranges above that minimum point of my average total cost curve. Prices above it result in positive profits. Prices below that result in negative profits. Okay. Well, we can see this on a table as well, right? So here I go back to using that same table we had before. Now I kind of left out the totals. I just did the marginal revenue and marginal cost, and I calculated the average total cost for it. So we said that we know, right, the point where profits should be maximized is the last quantity where marginal revenue is greater than or equal to marginal cost. Is at a quantity of 10. If instead of using total revenue and total cost to calculate profits, I could also simply take the quantity times the difference between the price and the average total cost. So notice here, the easy one's at 1. What's the difference between the price or the marginal revenue and my average total cost? So that'd be what? Negative 5.8 times the quantity of 1, negative 5.8 was my profits. Well, what about, it's another easy one here. I can do the math in my head. So we've got down here, right? I had marginal revenue, or that price, excuse me, was equal to 4. Average total cost was 374. So the what difference is positive 0.26. Positive 0.26 times 5 should give me that profit of 1.3. And et cetera, right? So I could go down here, difference between price and average total cost, 4 minus 3.05. That difference is 0.95 times the quantity I'm producing at that point, 10, gives me those profits of 9.5. So we can use our price and our average total cost to compute our profits instead of just using total revenue and total cost. Okay. And this is going to help us think about shutdown decisions in a different way as well. Okay. Is there anything else I want to mention here? I don't think so. Excuse me. So I'll kind of give you a couple depictions, and then we'll kind of move on. I think showing you some a little more difficult stuff. So let's say I had this example. I've got my average total cost curve, marginal cost hits it at its minimum point, and I've got a price of $4. Okay. So what is the optimal quantity? So these graphs, by the way, are not going to line up with this table. It's just they're completely different graphs. So it's just the numbers are somewhat similar. So if I looked at, okay, where does that marginal cost equal my marginal revenue? It's at a quantity of, looks like 11. Right? What's true about my price relative to my average total cost here? Well, the price of 4 is above my average total cost of like 3 something, right? So if I had, maybe the price was 3.05, or sorry, the average total cost was 3.05, my price is 4, I would find profits by taking that difference, multiplying it by the quantity I'm producing. So this kind of rectangle Well, what is its height? Its height is the difference between price and average total cost. And then the base, or kind of the length would be, or the width would be the quantity I'm producing. So profits are simply the quantity I'm producing times the difference between the price and the average total cost. Another way of thinking about that is price is essentially our average revenue. So if you take the difference between your average per unit revenue, your average per unit costs, that's essentially like your average per unit profits. Well, if this is how much I'm making per unit and I multiply it by the number of units I have, that would give me my profits. Okay. So, I don't know, maybe it's worth writing that out in words, but like if I have profits here and I'm taking the difference between price and average total cost, why does this work? Well, this is like my per unit revenues. This is my per unit costs. The difference between those two, that would just represent my per unit profits. So if this is how much I'm making on average each unit times the number of units I'm selling, this is just going to give me my total profit amount. Okay. So it's, maybe a kind of intuitive way or a different way of thinking about why that works. Okay. So here, anytime I've got a price above that minimum point of the average total cost, I'm going to end up with a rectangle here that represents positive economic profits. What if instead I had a price that was below, right? So this one doesn't quite, let me see. So I keep the numbers the same here. No, I copy and pasted and didn't update this. Let's say this was 275. There we go. Now this lines up with the visual, okay? So let's say instead of $4, the price is now down here at 275, right? Well, now where does marginal revenue equal marginal cost to the quantity of 8? What's true though, at that quantity, the price is below our average total cost. So we would still think about the difference between price and average total cost times quantity. This will still represent profits, this rectangle. However, because average total cost is above the price, it would be this is our profits, but they are negative. So it gets a little bit tricky if you're using a visual, a graph like this. If you're calculating profits using price and average total cost, you have to remember that if price is below average total cost, that rectangle is going to represent the area, that rectangle, that area will represent profits, but they will be negative. Okay. All right. So, we could put some values to this. Anytime average total cost is above price, you then multiply that by the number of units, we end up with negative profits. Okay. And then the break-even price, I kind of already mentioned this and kind of had a little drawing, but right, this is going to be the point. If I have the price being equal to that minimum point of the average total cost curve, then my marginal revenue would hit marginal cost right at that quantity where I have price being equal to average total cost. There, my profits are going to be equal to 0. Okay. Excuse me. All right. So with all this in mind, the next thing, the last thing we'll probably talk about today is going to be when profits are negative, the firm has an additional decision to make. Should they shut down or stay open? So I kind of mentioned earlier, these numbers we're looking at, we had like fixed costs when we produce nothing. So we were in the short run. Okay. So in the short run, what can be true is that sometimes what actually maximizes profits is to produce nothing at all. So when we're identifying these profit maximizing points when the price was below that minimum point of the average total cost, this is going to be the optimal quantity if we stay open. So we kind of have to add on this caveat. Finding where price or marginal revenue is equal to marginal cost, that will be the optimal quantity if we stay open. Now, when profits are positive, come on, there we go. We know we're going to stay open, right? We're not going to shut down. If we shut down, our profits are negative, whatever our fixed costs are. But if profits are negative, we have to kind of compare what are our profits from shutting down, or what are our losses from shutting down, and what are our losses or what are our profits if we stay open. Okay. So we can identify what our profits will be if we stay open. What would our profits be if we shut down? Well, that's simply going to be negative whatever our fixed costs are. So we're ultimately going to compare our losses from staying open to our losses of shutting down. Kind of walk through this with some visuals here in a second and some actual numbers. But just some examples, like why do we talk about this? You know, if a firm shuts down, why do we care? They're gone. Not necessarily, right? Firms shut down in the short run all the time and still remain open for years. So usually these are like seasonal examples. So ski resorts, right, shut down in the summer because, well, what happens in the summer, the additional revenue they can make goes down dramatically. Or restaurants in resort towns, or even Bloomington. A lot of the restaurants will have different hours when it's not in the fall and spring semester, when there aren't as many students around, right? So even if you think about it's not just an open, completely open or completely shut down, it could be that we're just deciding whether or not we stay open for this hour or for this 2-hour time block, et cetera. Okay. So what is our shutdown rule going to be? So I'll walk through it and then I'll give you some numbers that I think will help solidify it. But as you know, anytime our price is below average total cost, we said we had negative economic profits. If we kind of take that equation that we were using to calculate profits, I'm going to rewrite it slightly and it'll give us some insight into why we will have the shutdown rule that we have. So I can rewrite average total cost as my average variable plus my average fixed. So if I'm subtracting average total, that's the same as subtracting my average variable and subtracting my average fixed. Okay. If I then take quantity and kind of multiply that, right, distribute it, multiply it by my average fixed cost, quantity times my average fixed cost would just give me my fixed costs. And then I'm going to kind of remain kind of keeping this here the same. So this form of the profit equation, it's the exact same thing, just rewritten. So if I shut down, what are my profits? Simply my negative fixed costs, right? If price is below average variable cost, what's going to be happening to my profits? Well, if I stay open, I'll have negative fixed costs plus some quantity times, oh, if price is below average variable, another negative value. So now my profits will be even larger of a negative value, or my losses are going to be higher. So another way of thinking about this when we're talking about losses, if I'm maximizing my economic profits, I'm minimizing my losses. Saying the same thing, just slightly different. If price ever is above average variable cost, well, now if I stay open, right, I'm going to have my negative fixed cost plus some positive amount. Well, that's going to be a profit that's higher than if I just shut down, because if I just shut down, I would just have negative fixed costs. Okay. So anytime price is above my average variable, I should stay open in the short run. That would actually be minimizing my losses. Sorry, we'll go with that in a second. So another way, just some numbers, kind of put this. Let's say I had, let's say I'm at a quantity, just to make it easy, of 10. I've got average variable costs of, what do I want here? 30. And let's say my average fixed cost, not my average fixed cost. Let's just say my fixed costs are 100. Okay. So let's think about two scenarios. Let's say the price, and I'll kind of use them to make a point that if they went any larger, we could see what's going to happen. So let's say price was 29. Okay. Well, if I shut down, what are my profits? Well, simply negative whatever my fixed costs are. Okay. So the kind of profit equation we were using was, so we could take the quantity times the difference between price and average variable minus my fixed costs. Okay. So if I shut down, quantity is 0. So all I have are negative fixed costs. If in this scenario I stay open, we said that if the price is below average variable cost, I shouldn't stay open, right? I'm actually just going to be creating even larger losses. We can prove that to ourselves here. What would profits be if I stay open? Be what? 10 times 29 minus 30. And then I still have these negative 100 fixed costs. So I'd have what? This would be one time. So this would be negative 110. So they're not a lot lower, but my profits are lower here if I stay open. So price was below average variable cost. So I should be choosing to shut down. Sure enough, that's where my profits are a little bit higher, right? They're still negative, but I'm minimizing my losses. Okay. What if instead the price was 31? Well, we have here, price is above my average variable cost. So we said we should stay open, but we can kind of prove it to ourselves. If I shut down, my profits are simply negative, whatever my fixed costs are. If I stay open, it would be the quantity I'm producing, 10, times the difference between price, average variable costs, right? I also still have those fixed costs that I'm losing. Well, now here, this would be positive 10. So here my profits would only be negative 90. Still negative, but losing $90 is better than losing 100. Okay. So using these values, you can kind of prove to yourself from our profit equation that anytime price is below average variable, you're better off shutting down. Anytime price is above average variable, you're better off staying open. Okay. Any questions on that idea before we keep moving here? So just to kind of give a visual, a graph depiction of this, we've got average total, average variable. Remember, we said average total is average variable plus average fixed, so it'll always be the higher curve, and then the gap in between them is getting smaller and smaller because average fixed is getting lower and lower. So we really have three ranges when we put all this together. If the price is ever $3 or higher, then that marginal revenue is going to hit my marginal cost curve at a quantity where that where that price, right, where the price or marginal revenue hits marginal cost is above the average total. So there we know profits will be positive. So anytime price is above the minimum point of your average total cost, your price or your marginal revenue will hit marginal cost at a point that's above the average total, so you know profits will be positive. Anytime you have a price below average total, well, now that price or your marginal revenue will hit marginal cost at a quantity where that price is below average total. So you know profits will be negative for all of these prices. However, as long as that price is above average variable, we said, well, then you're going to be adding a small positive amount to your large losses. So at least you're minimizing losses here. Anytime price is in between that minimum point of your average total and average variable cost, right? Then you have a price or marginal revenue that hits marginal cost above average variable. This is going to be where profits are negative, but you're minimizing your losses by staying open. And then anytime price fell below average variable, so anytime you have a price below the minimum point of your average variable, it's going to hit your marginal cost curve down here. Well, if I'm down here, that's at a price below average variable. We said there, I'm just adding larger negative values to my already negative profits. So that was going to be the range where I should just choose to shut down. So these are really kind of our three different areas. Price above the minimum point of average total cost, profits are positive. Below average total cost, profits are negative. And then we can differentiate that area into two different groups. When price is below the minimum of average total, but above the minimum of average variable, that's where we should stay open to minimize our losses or to maximize profits. Anytime price falls below the minimum point of the average variable, we should just shut down. And then I think I have kind of like a little summary of that over here. Okay. All right. So with this idea in mind, let's go take a look at the participation quiz for today. And there is a small issue if you were trying to do this without working along with me. But I'll mention on question 3, I'll give you the value. The visual is not perfect. I was trying to just, find some quick little easy grid lines. I'll on the quiz or the exam, I'll mention what I would do instead. But before we get there, okay. So we've got 3 questions here. So the first one is going to be, what is the break-even price and quantity of this visual depiction of a firm's cost? Now, I didn't label the costs here, but I should be able to identify from these which is the average total, average variable, and marginal cost curve. Well, first of all, this blue curve is hitting the other 2 at their minimum point. What does that? Oh, the marginal cost hits my average variable and average total costs at their minimum point. So this blue curve is my marginal cost curve. Well, if I'm then thinking about, okay, I've got average total, average variable, what has to be true about average total costs? They have to be greater than my average variable. So if I've got average total costs, and I know they have to be greater than average variable, this black curve will be average total, green curve would be average variable. So the break-even price, the point where profits are equal to 0, is at the minimum point of that average total cost curve. So I'm looking for what is that price? It's going to be $425 and at a quantity of 350. Okay. So that break-even price, or where profits become positive, right, where they're going from 0 to would be any price above 425 or producing at a quantity above 350. Any questions on that one before we keep moving here? All right. So what if instead what if this firm's marginal revenue is 125? Now, I told you it was marginal revenue here. The question really could say, what if the equilibrium price was 125? Because we know that equilibrium price will be that firm's marginal revenue curve. So we know the optimal quantity will be where marginal revenue is equal to marginal cost. So two things to point out with this question. There's a reason why I chose 125. If I have 125 as my marginal revenue, I would have kind of this horizontal curve here. Notice it actually hits marginal cost at two different quantities. Now, this shouldn't ultimately matter in most of the problems that you'll see. However, if it did occur like this, why do you know you won't just stop when your marginal revenue hits marginal cost here? If you're looking at where the marginal revenue hits your marginal cost curve, the point you're going to stop at is once diminishing returns take over. If you still have gains from specialization, this is the idea, okay, just because for the first worker I hire, maybe that marginal cost is the same as my marginal revenue here. If I continue to produce, that marginal revenue would be greater than the marginal cost for all of these units. So we know that firms will never stop production at a quantity that's on the gains from specialization portion, because if I keep producing more, I can lower those marginal costs, right? Just because the marginal cost is equal to marginal revenue at this point, if I keep producing, that marginal revenue of 125 will be above the marginal cost for all of these units. Okay. So I'm going to look for where does marginal revenue equal marginal cost on the diminishing returns portion of my marginal cost curve, which looks like it's going to be out here at what? 225 units. Okay, so that's where marginal revenue or the price is equal to marginal cost. I'll stop at 225 units. No, right? Because if I look at that marginal revenue, that price, is it above or below my average variable? It's below, right? In fact, it's below my average total by a lot. So I know profits are negative. So I then have a second decision. Do I stay open or shut down? Well, not only is that price below my average total, it's also below my average variable at that quantity of 225. So if price is below average variable, we said the optimal decision should be that I shut down and produce nothing. Okay. So what's the first, what price would be the cutoff, or if I see a price above that, I'll actually stay open even if profits are negative? It would be any point above the minimum of my average variable cost curve. So any price above 175, but below the minimum point of my average total cost, which is about 425, any price in this range, I would stay open but have negative losses, or negative profits, or I'd have losses. Any price below that minimum point of my average variable cost, I should be shutting down, which is why at that price of 125, we would just produce nothing and shut down. Okay. All right. So what about this third one? So this is going to get a little bit trickier. Let's say I had this marginal revenue or this marginal cost of 350. Okay. So I look here, that price, my marginal revenue would be 350. It would hit my marginal cost curve at a quantity of 325. Okay. Now here's where I'd give you a slightly more, a better visual. If I was doing this on an actual quiz or an exam, but since we're walking through it together, I'll kind of explain it. Well, how do we calculate profits, right? We said it's going to be the quantity, the optimal quantity to produce. So we said at a price of 350, that was a quantity of 325, times the difference between that price and our average total cost. So at 350, what's our average total cost here? Well, technically, it's at 425 here. So it's something just barely above 425, right? So I think the value I chose here, if I am just using 425, whoops, just to kind of give you, oh, where do we want this? There we go. Oh, come on. Okay. So we had, my quantity was 325. If I were to take 430 minus 350, I think this is the value I chose. Yeah. So here, I know that this is 425, right? So if I'm looking at the quantity of 325, it looks like I'm at just above 425. So I said it's about 430. Obviously, I said in an example on a quiz, or I'd have to make sure that it's very clear, right? That it like crossed right at a point where you could get the exact value. Since we're walking through this together, I'll kind of tell you instead of 425, it was just barely above that. So I'm kind of using the value of 430. So 26,000 would be the value of profits there. However, got to be careful. What did I do wrong? What is the actual equation for calculating profits? It's quantity times the difference between price and average total cost. I put average total cost first here. So it actually should be 350 minus 430. Now I'll get the same value, but right, whenever that price is below average total cost, it should be that those profits are negative. So there, the answer should be negative 26,000. Okay. And I think I put a comma in here. I'll go back and make sure. I might have to edit this after the fact. If you do put in like 2600, negative 26,000, I can add in that it accepts multiple answers. I think I might only have it so it takes the one with a comma right now. But I'll make sure once that due date passes, I adjust that to accept those other forms in case you hit submit before I'm telling you this right now. But right, negative 26,000 would be the value of our negative profits if we had that price. Okay. Okay, good. I couldn't remember if I put that setting on there or not, so I just wanted to preface that and say if that does happen, I will take a look at it. I'm aware of that. Okay. All right. Anything else I want to say here? Don't think so. Yeah, that should be good. So that should be good for that quiz. Once again, these participation quizzes will be due at the end of the day Sunday, just in case people are, giving them a little more flexibility if they weren't here today. Going back to the slides, we're talking about this shutdown rule. I'm gonna do long run stuff next class. We'll do firm entry and exit. I know there was something that I wanted to, if we had time, go through. Oh, I know what it was. So let's say I had a visual depiction and I had the quantity. Here's their marginal cost. Here's their average total cost. Here's their average variable cost for a firm. I just wanted to kind of think about this in a slightly different context and relate to some things we've already talked about. So let's say I didn't tell you what the fixed costs were. Right? And I said, okay, assume that you've got, a price down here at like 125. I'm just going to come up with some values here. And you're like, oh, well, marginal revenue is that price for the firm. It's hitting marginal cost below average variable. So if price is below average variable, I know I should shut down. What should my profits be if I shut down? Simply my negative fixed costs. Well, where are my fixed costs here? I don't have them, but they're kind of hiding. Okay. So if I look at any quantity on this graph, so let's make the values easy for us. Let's do 300 here. And let's say the point that I'd be at, well, let's do this. So the point that I'm at my average variable, let's say this was 200, right? And let's say this was, just to make the math easy on myself, also 300, right? How could I find my fixed costs? Well, my fixed costs, another way I can write that, we said was our average fixed cost times the quantity we're producing. Okay. So remember why? Because what is my average fixed cost? My average fixed costs are just my fixed costs over quantity. So that's why that works. How can I find my average fixed costs? Well, my average total cost is simply my average variable plus my average fixed. So if I want my average fixed, that's just the difference between my average total and average variable. So in this example, I'm looking at this quantity of 300. What's the difference between average total and average variable? That should represent my average fixed cost. So that would be what? 100 here. Right? So negative 100 times 300, right? I end up with what? Negative 30,000 would be my profits. So even if you aren't given directly fixed costs, if you have information about average total and average variable, you can always back out what your average fixed cost is. And then at that quantity, take the average fixed times quantity, should always give you that same fixed cost of 30,000. You know that if you ever are at a price that's below the minimum point of your average total cost curve, you should just shut down, and there your profits would be negative whatever your fixed costs are. Okay. So in our example, in the quiz, well, actually we can do one here. Let's see. Nah, I could use the quiz again. We've got 2 minutes. I think it's worth it. So if we look at that quiz, if I did have a price where I should shut down, like in problem 2, what would be my profits? Negative fixed cost. I could choose any quantity where I can clearly kind of identify. So I'm going to choose this quantity here. So it looks like it's at 250. My average variable is 175. My average total is 450. What would I do? I would just take the difference between my average total and my average variable. So we had what? 450. I already forgot what I said. Minus 175. That was going to give me my average fixed cost, the difference between my average variable and my average total. And that was at a quantity of 250. So it must be that my fixed costs in this example are what? 68,750. So if I do shut down, my profit should simply be, I'm just losing those fixed costs. So negative 68,750. Okay. So that's another thing that, we could use based off what we've talked about. If you had an example where you shut down, you can always calculate what your profits are, negative fixed cost, even if you're not directly given fixed costs and all you have are the average total and average variable costs at different quantities. Okay. Any questions on that before we kind of wrap it up here? So once again, what I was doing there was just choosing a quantity where I could find both the average variable and the average total. I chose this one because it's very clear like where they intersect the grid lines. But if I could identify at different points where they also intersected the grid lines at obvious points, I would find the exact same value. Okay, so I can choose any quantity I want in order to calculate those fixed costs. Okay. And I'd be more likely to give you a numerical example, which we'll walk through some of those tomorrow. I think we'll get through these slides pretty quick tomorrow. We've only got like what, 13 left. And really a lot of this is going to be like firm entry and exit. It's just different ways of depicting it. So I'll work through, do a lot of graphs for you tomorrow. We should have some time where I can then work through those practice problems. So those practice problems have a lot more just not tables or not visual graphs. They just have some numerical examples where I'm telling you what average total, average fixed, et cetera are. So we should have some time to kind of work through some of those practice problems together tomorrow and help solidify some of the things that we talked about today. Okay. All right. Any questions before I end the recording here?